Hello everyone, and welcome back to the garage. This is part 3 of the restoration series on this Gottlieb Close Encounters of the Third Kind pinball machine. Now I left you kind of on a cliffhanger at the end of part 2 because I said we were going to turn the system on. So I'm not going to waste any more time. Let's get started and finally get this machine powered on for the first time in 40 years. Alright, moment of truth. I'm going to go ahead and plug in the power cord. 3, 2, 1. That was very hard to get in the socket, but it's plugged in and nothing bad's happened, so that is good to see. So now, here's the real moment of truth. I'm going to go ahead and push the under cabinet switch, and we'll see if this thing comes to life. Look at that, we have lights. Looks like all the general illumination is working, so that's nice to see. Don't want to let it run for too long in case there is something wrong with it, but that's all it's going to do without the boards in it. So I have this machine running again, and as you can see, the 2 coin door lights are on. And I looked around in here for a second, and I can tell you that the soundboard is working at least somewhat, because if I turn the potentiometer on the soundboard, listen to the level of hum from the speaker. Hear how it gets louder? So that means we're getting signal through the amplifier to the speaker. So that's great. So the soundboard on this machine, unlike the Phoenix, should actually work first try. So that is what the back box looks like when it's lit up. As you can see, most of the lights are working. This one, for some reason, is not working, and it won't start working even if I shake it around, so I might need to file the inside of that socket down so it actually makes a connection. These ones aren't lighting because they're computer-controlled lights. These ones are computer-controlled lights too, but I think that they're supposed to be lit right now because those are the lights for Game Over and the match light. The displays are not running because we don't have the boards in, so the only thing that we should see is the general illumination, which is lit right now. And so this is how the playfield looks when it's lit up. All right, I went ahead and made some changes to this machine. The first thing I did is I took out all of the retro LEDs that I had in there, the tall ones, and that's because I realized they are not as bright as a regular pinball LED. And so I figured out that the regular ones will actually fit. If you look right here, you can see they just barely stick up out of the playfield. I'll go ahead and turn the game off so you can see that a little bit better. As you can see, they do actually fit, but just barely. So I went ahead and replaced all of the upper playfield lighting with the regular LEDs, and now it's like twice as bright. So this is what it looks like now, and this is as bright as it is going to get. The slingshots especially were very dim, and now they look much better with the regular pinball LEDs. The other thing I changed is I went ahead and added some brand new 455 blinker bulbs in those 4 spots right there. So if I open this up, you can see these bulbs will blink at random intervals. And it's the bulbs that do that. They aren't being controlled by anything. It's just how they're made. This game had 4 of those bulbs in there when I got it. 2 of them were burned out, so I went ahead and just put 4 brand new ones in there. So that's what those look like. And I also figured out that these 2 lights, the match light and the game over light, they are controlled by a relay underneath the playfield, just like an electromechanical pinball machine. It is the game over relay. So right now it's not doing anything because the game doesn't have any way to control anything. But if I manually go ahead and push in the relay, it will turn these lights off and light the ball and play light here. So we know that that's working right. And there's another relay underneath the playfield right next to the game over relay. It's the tilt relay. And if I push that relay in, it will light the tilt light, which is right here, and it will also turn off the playfield general illumination. The back box will stay lit. So I'll go ahead and put the camera on the tripod and show you what that does. Actually, the tripod's not going to be able to show this very well, but I will show you the location of the 2 relays under here. There they are right there. This is the tilt relay, and that's the game over relay, and there are 2 coils that will push those in. So if I go ahead and push the game over relay, see how it turns those 2 lights off, and now the ball and play light is lit. So now if I let go, it goes back to the game over and number to match. So when the game is being played, the relay will be held in like that so that the ball and play light stays lit. And so now if I push on the tilt relay, you can see the tilt light is now lit and the playfield GI is off. So if I let go, the playfield lights come back on, the tilt light goes away. So we can see that it's working just fine. So that is what those relays do. And the only other lights that we haven't seen light up in the back box are the shoot again light and the high score light. And those are computer controlled, so those will not light unless the boards are in the system. So all the lights in this machine are working fine. All right, I've gone ahead and installed the new capacitor right here, and I learned that that is the high voltage input capacitor. So that capacitor being leaky may have been the reason why the display voltage fuse was blown when I first took a look inside this game. So I mounted the power supply back in the machine, but before we plug it in, we need to check the voltages that are going to it. So here's the schematic for the power supply for this game. And so what we need to do is turn the game on and check the voltages at these 5 pins and these 2. So as you can see on pins 2 and 1, we have 11.5 volts AC going in. And on pins 4 and 5, we have 14 volts AC going in. And then on pins 6 and 7, we have the 69 volts for the displays. So I'm going to get my meter and we're going to check all those and see if they are correct. All right, so with the meter set to AC voltage measurement, we're going to be checking this connector right here, A2, which is the identifier for the power supply, and J1, which is this connector. So this may not necessarily be in the exact order that was shown on the schematic because the schematic references connector A2-P1, and I think that is one of the connectors inside the machine. So we might not see it in the exact order, but we should see 2 instances of 11 volts, 2 instances of 14 volts, and 2 instances of 69 volts. So what I've gone ahead and done is I've hooked the common lead up to this grounding wire right here. And I am aware about the System 1 grounding flaws because Gottlieb in these machines only uses little wires like this to connect each part of the back box ground together. And the boards never communicate with this ground because they're situated off of it with these little white plastic clips. So I might go ahead and do the grounding mod to the 3 boards in this machine, but I want to see if we have correct voltage first before I do that. So let's measure each of the pins in this connector and see what the voltages are. So we'll do the first pin, 12.5 volts. So that must be one of the 11 volt lines, and 12.5 is only just a volt off, so that is okay. The next pin, 12.5. Third pin is ground, so that's why it says 0. Fourth pin, 15 volts. That's okay because it's the 14 volt line. And there is no load on the transformers, so that's why the voltages are a little bit higher. So once I actually plug this into the power supply, we should see that drop a little bit. So let's do the next pin, 15.1. Next one, this should be high voltage, I would think. 38 volts. Let's see what the last one is. 34. Well, taking a look at the schematic, that 38 and 34 volts that we are seeing is actually okay, because as you can see, it goes through 1 pin on J1, which is the power supply connector, and then it goes through the fuse to another pin. So I think that is a center tap voltage. So 38 plus 34, that's 72 volts. That is perfectly fine. So the voltages going into the power supply unit are fine. So let's go ahead and hook it up and see what voltages we get out of it. So with the game off, we're going to go ahead and plug this connector into the power supply. And it's worth noting that on some of these earlier power supplies, you can plug this connector in backwards. This is not one of them, but if your connector here says this side up, make sure you plug it in with that side facing up. Because if you don't plug this connector in the right way, it will damage things. So if you have the earlier power supply, make sure it is in correctly. So the game is off, of course, but with this connector connected, now I want to see if we get the right voltages out of these two connections. This connector's for the displays, and this connector gives power to the CPU board. So all the voltages are labeled on both of these connectors on the board. So this top connector provides plus 5 volts and minus 12 volts. And this connector provides 60 volts for the main displays, 42 volts for the credit and ball and play display. And it looks like it also provides 4 volts and 8 volts. I'm not sure what those are for, but we will check those as well. And of course, that is going to be DC measurement. So I'll switch the meter over to DC. So now let's turn the game on and see what happens. So there should be nothing different at this point other than now there's power going through the power supply board. So we'll check the first 2 pins on the top connector here, and those will both be 5 volts if they're working right. 5.4, that is okay. The other one, 5.4. Now, the next 2 pins should be ground, so it should be 0. Yep. And keep in mind that we're not loading the power supply right now, so that is probably why it's a little bit high. This next pin should be negative 12 volts, minus 11.9. So the low voltage is working fine. Now let's check the higher voltage. So this top pin here should be around 60 volts. And we don't have anything, really? Well, it is possible that the 60 volt adjustment potentiometer right here needs to be adjusted. So what I'm gonna do is I'm gonna hook a clip lead from this pin of the meter to the 60 volt pin, and we're gonna adjust this pot and see if we can get voltage back. Actually, before we do that, let's test the other voltages and just make sure they're there. So this pin should be 42 volts, and we get nothing. So we definitely have a high voltage issue. Looks like the next few pins are ground, so we'll just make sure that those are actually grounded. It looks like they are. Oh, this one's got voltage. Negative 1.7 volts, interesting. This next one is nothing, so that's probably ground. This one, there's our 4 volts, so that is working. We have 3.8, and that is fine. And this last pin should be 8 volts, 8.2. So the lower voltages are working just fine, but we have a problem with the high voltage. So I'm gonna adjust this potentiometer and see if we get voltage. So the clip lead is now attached to the 60 volt pin, and the sheath of the clip lead is covering most of the lead. So even though it is touching another connector pin, it's not gonna transfer any voltage because of that. So I'm gonna go ahead and adjust this, and we'll see if we get more than half a volt. It looks like we do not. So the adjustment pot is not doing anything. And so that means we have a problem with the high voltage on the power supply. We have good voltage going in, but we have nothing coming out. So the power supply has to come out again so we can troubleshoot it. Well, I think I found where the problem is. You can see here we have 69 volts coming in, and it's going through diodes CR7 and CR9. And so if we measure at the banded end of CR7, we can see here that it is labeled as 90.4 volts. So if we measure the end of CR7 with the band, we only get 2 volts. So our problem is in the very beginning of the power supply, because we are not even getting high voltage past the diodes. So something is wrong here. All right, I did some more reading on this machine, and it turns out that the 60 volts and 42 volts use a different ground than all of the other voltages. So that would explain why we were seeing nothing when probing those 2 pins. So the ground that is used for the 60 and 42 volts is actually the one on the connector itself. So what we can do is probe between that pin, which is here. I should do that with a clip lead. We still get nothing. So there actually is a problem here. 42 volts, nothing. Oh, I moved the ground pin down one, and now if I probe this pin, 61 volts. So it looks like it's actually working. That's good. I didn't want to have to take this apart again. The 42 volt pin, 43.8. So the high voltage on the power supply is actually working. So with that, that means the power supply is working fine. So that's one board out of the 3 tested. All right, so as I'm going through and repinning those 3 faulty connectors, I went ahead and put all the boards back inside the machine. Now, I'm not ready to test everything yet, but while those connectors are being repinned, I think now would be a great time to test out the control board and the displays. So in terms of the control board, all I'm going to do for right now is just run power through it and see if we get 5 and 12 volts on the control board, and we'll just see if it's not bogging down the power supply. So to test that, all we have to do is hook this connector up right here to the control board. And so with that connected, now when I turn the system on, the control board will receive power. Nothing else should be different from what happened last time, except for now power is going to the computer. So let's go ahead and turn this on. Okay, the game is now on. So what we can do is, because this board uses the same ground as the frame of the power supply, we can hook the ground right here. And what we can do is measure the voltage coming off of these capacitors to see if we're getting the right voltage. So let's just see what we get. 5.1 volts, that's good. I think this one's the negative 12 volt one. Maybe I have to go down here. Negative 11.9. Okay, so the board is not drawing excessive current from the power supply. So now what we'll do is we'll test the displays. And so to test those, we have to connect these 2 connectors to these 2 spots on the control board, and then the displays will be hooked up. Now, one weird quirk about these Gottlieb System 1 machines is that in order for them to boot up properly, the slam switch in the coin door and the ball roll tilt switch have to be closed. Otherwise, the game kind of freaks out a little bit. And because we don't have the driver board connected and any of the solenoids connected, the game will boot up as if the slam tilt switches are open. So what we'll see when we hook up the displays is when they first come on, they'll flicker a little bit. They won't be steady on. And that's just due to the slam switches not being installed right now. If we have the driver board connected and the solenoids connected and those switches are closed, then the displays will be steady on. Another thing that this machine is supposed to do when the slam switches are closed is it'll have a 5-second delay before the displays come on. With the driver board and the slam switches disconnected, the displays will come on immediately. So what we should see when I hook these 2 connectors up is the displays will come on immediately and they will flicker while they're on. So what you want to do when you test your displays is you want to do it one at a time. So as you can see, I went ahead and disconnected all of the displays. So the first one we're going to test is the player 1 display. So let's go ahead and hook this up. So now I'm going to turn the game on, and if the display is working correctly, it's going to come on immediately after I turn the power on, and it will kind of flicker while it's on. Maybe the display isn't working, because I think with the configuration that we have it in, the display should come on. I'm going to check and see if the high voltage fuse blew when I turn the game on. It does not look like it blew. Okay, the high voltage fuse is good. The display is not on. So what I think might be happening is over time, when you have these Gottlieb System 1 displays, they can fade, and so they won't be visible anymore. So one thing that you can do and I might do to this display after I test the rest of them, is if you have the game turned off, you can unplug this connector, and then what you can go ahead and do is get a 12-volt DC power adapter and hook each lead of it with clip leads to the outermost pins of the display here, and then you want to run that for 10 seconds, and then what you'll see is the filaments inside the display, they'll glow bright. And so after that 10 seconds, you can unplug it, then put this connector back in, and then turn the game on, and then the display should be nice and bright if it's actually working. So as you can see, we're not getting anything out of this display. So that could mean I have to do that little rejuvenation process, or it's just not working. I think we'll go ahead and we'll test a different display and see if it'll come to life. All right, so now I have the player 3 display connected, so that's the one on the bottom left. So I'm gonna turn the game on and we'll see if it comes up. It did not come up. It's possible that it came up and it's just really dim, but I don't see anything. High voltage fuse is still good, so the display did not blow the fuse. Let's try another one. It is also completely possible that we have a problem on the control board that's preventing the displays from coming to life, but I kind of want to just go through each one and just see if they're all working. So now we'll do player 2. Okay, that one didn't come either. Well, let's just go through each one and just see if we have at least one that comes to life. So now we'll do the player 4 display. Okay, nothing from that one either. It's also very possible that all of these just need that rejuvenation because this machine has been sitting since the 1980s and it hasn't been used since, so that could also be possible. All right, and what about the credit display? This one is on the 42-volt rail, so it takes less voltage to run this one. Let's see if that one works. And that is a no. Let's just make sure the high voltage fuse is still good. It looks like it is. So, I'm not really sure. I think we're gonna have to go through this board a little bit more so we can figure out what's going on with our displays. Okay, so I have all the displays hooked up now, and I'm gonna turn the game on. And as you can see, we get nothing on the displays. Watch what happens when I turn the game off. Just watch the displays. I don't know if you can see it. We get a little bit of life out of it. I can see some zeros light up on there for a split second. So it doesn't look like they need rejuvenation. I am getting a little bit of life out of those displays. So there could be something wrong with the control board. Maybe the voltage isn't making it to the displays. I'm not sure, but you would think that it would be, because if the voltage wasn't making it, we wouldn't get that little split-second life out of the display there. So I'm not really sure. I'm gonna have to take a look at voltages, take a look at connections, and just see what I find, because the stuff that I have connected right now, there's nothing else that the displays need in order to work properly. These are the only 2 connections that go to the displays. The only thing that would change if I connected the rest of these would be that we would have the 5-second delay between turning on the game and having the displays come up due to the slam switch being connected. So I'm gonna have to take a look at the control board, and I'm gonna have to take a look at stuff on the displays, because maybe it's a display issue, but that's kind of hard to believe if every one of them is not lighting. So I'm drawn more towards an issue on the control board, so I think that's where I'm going to start my search, but I'll take a look around some of the stuff in this machine and I'll let you know what I find. All right, so as you can see, I'm starting to repin the connectors for the CPU board that need to be redone, and at this point I am about halfway done with one of the connectors. You can see the good contacts versus the corroded ones. And so at this point, I've gotten the process down, so I'm going to show you how I repin these. So normally you'd want to have the right tool for removing those crimp terminals, but I could not get that tool to remove them, so I just resorted to a big metal pick, and I know that's not ideal, but it is what was able to remove the pins from the connector. So I removed them with the pick, and then I pulled them out of the connector. I stripped them back with a wire stripper so I could have a good section of wire to put the new crimp on. So I got the new crimp and I used a pair of pliers to kind of pre-tighten it on the wire so that it wouldn't fall off. And then I took the wire, I put it in my crimp tool, and first I just made it snug in there so that it wouldn't fall out of the tool. And after making sure that things were correct, I gave that wire a nice crimp with the tool. And as you can see, I am left with a perfectly nice crimp. So then all I have to do is just put the wire back into the connector and wiggle it a little bit just to ensure that the locking tab on the crimp was able to lock. And so now it's in there, and that is another contact repinned. And I had to do this to 45 wires in the back box. So you can imagine how long that took. All right, so I let this game run for 12 hours overnight just to see if the displays would come back, because I heard that is a valid technique you can do to rejuvenate these, but that didn't do anything. So that leads me to think there might be a problem on the CPU board. And if that's the case, we're about to find out, because I just finished repinning all the 3 connectors that needed to be repinned. So these 2 here, A1, J6, and J7. You can see those have nice, fresh new contacts in there now. And then I also finished repinning this section of the harness. So this hooks up from the CPU to the driver board, so that's been repinned. So now we're ready to start hooking some more stuff up to this board. So I don't think we have a problem specifically with the displays. I mean, it is possible that every one of them is just very tired and they need like a really good rejuvenation, but I don't want to do that to them too long because that could damage them. One thing that I did check on the display connectors, there is 60 volts on these connectors here going to the displays, and I know there's 42 volts going to the status display, because I can see that display flash for a little bit when it gets turned off. So obviously there's voltage going to every one of these. And I also looked at the filaments. You can see the horizontal little lines that go across the displays. All of them are still intact on every display, so I know the displays are not dead. So we might be able to get these working, we might not. I'm hoping that we can. So now what I'm gonna do is I'm going to hook up the harness between here and here so we can get power to the driver board, and we'll just see what it does. It shouldn't do anything different. Well, I've gone ahead and I also hooked up J6 and J7 to the CPU board, and those connectors are for the switch matrix. So with those connected, now the slam tilt switches are wired to the control board. So the system should act a little bit better when starting up if it's working fully, because with the slam tilt connectors in place, then the system will boot normally. So the only things I don't have plugged in at this point are the solenoid and lamp connectors on the bottom of the driver board. Everything else is hooked up. So I'm gonna go ahead and turn the power on and we'll see what happens. No displays. So if I go ahead and close this here, you can see still no displays, but everything else is running. I'm gonna check and see if the fuses are still okay. Looks like they are. So nothing went crazy boom when I plugged that in. The driver board has power and nothing is hot on that board. Okay, so now I'm gonna go ahead and go for broke. Turn the game off here. I'm gonna hook all the solenoid and lamp connectors up and we will just see what this thing does. All right, everything is hooked up. So I'm gonna go ahead and close the door just so we can watch the game when it starts up. So how this game should work when you power it on and have everything hooked up is when you turn it on, there should be a 5-second delay. Then you'll hear the game over and tilt relays click, which will turn the playfield general illumination off for a second, and then the display should come up. I don't know if we're gonna see anything on the displays, but we should see that 5-second delay and relay click when the system powers up. So I'm gonna go ahead and just scoot the tripod back a bit so we have more of the system in view. Okay, let's go ahead and hit the power switch. And if the knocker coil sticks on, if it locks on, I'm gonna turn it off right away. Okay, it did not do that, so let's see if the system does its click. It does not do its click, and I can see that we have a problem because some of the lights are on and they should not be on. So I'm going to turn the game on again. You can see now we have another light lit up here, and that is the high gain to date light. So the computer is not starting up because it is stuck in that mode. And we also did not get the relay click from underneath the machine. So the machine is not booting right. And if I tilt this down a little bit, you can see the 1000 and 9000 lights are lit, and they should not be. There should be no lights lit except for the general illumination when the system is in game over mode. So something isn't right. Well, one thing we can do right now is we can check the transistors on the driver board, the solenoid transistors, and we'll just see if they work. I just did the knocker coil transistor, and it does indeed work. So what you can do, this is a crude way to check and see if your solenoid transistors are good. Take a clip lead and hook it to a ground source, and then just tap on the top side of the transistor here. That's the knocker. So as you can see, this transistor is good and the knocker coil works. This next one, I'm referring to this little sheet here that shows what it does. It's the tens chime coil, and this system doesn't have a chime unit, but it's got the soundboard. So I wonder if it'll make the sound if I do this. It does. This next one, hundreds, thousands. So it does make sound. So those transistors are working. This one here is for the outhole kicker, and that is working. This one is shoot again, and I think that's a light on the back glass. Yes, I can see it lighting up. High game to date. I think this transistor might be bad because that light is always lit. So we might have a bad transistor here. This one is the game over relay. Yep, I can hear that click. And this is the tilt relay. Yep, that works. So it seems like all the solenoids are working. Let me just check these unmarked ones and just see what happens. That does nothing. That does nothing. That does nothing. I'll have to see what those specific transistors are for. But we were able to figure out that a good majority of the solenoids in this game are actually working, and that includes the knocker coil. So the transistor for the knocker coil is actually okay. And so I guess the old knocker coil just started to decay and then eventually shorted itself. So I think what I'm going to do for now is I'm not going to worry right now about these two lights that are on when they shouldn't be. And there's also another light on the back box that should not be on, and that is this one here. That is the high game to date light. That should not remain on. That should only come on when the displays show the high score. It shouldn't remain on like that. So I think what I'm going to do for now is troubleshoot the CPU board, because obviously that's the main problem, because the game is just not starting up. So I think we're going to focus our problem searching there first. All right, well, this game has had 2 more failures since I've been poking around and testing it. This light is on now, so that means another bad transistor, and I know we have at least 4 bad transistors on the driver board. And then when I was poking around and trying to make some of the other solenoids working, this game is wired so that once the game over relay pulls in, it will do that when you start the game. It will give you control to the flippers. And so I tested that, and both flippers work just fine. And it also gives control to the left slingshot. This one does not have a coil in it. And the 2 pop bumpers. Well, the left slingshot works, but I was having trouble getting the pop bumpers to work, and I found out that it's just because it had dirty switches. So I filed those down, and the moment I pressed on one of the bumpers, the bumper thumped, but it made the coil for the drop targets stick on. So now whenever the game over relay is on, the coil that resets these is stuck on, and this transistor here gets burning hot. So I think this transistor just shorted. And I did see that it is both this transistor and this transistor that control solenoid 8, which is the drop target reset coil. And so we could either have a problem with this one or this one, but I'm suspecting this one because this is the one that gets burning hot and not this one. And the CPU board still isn't doing anything. I'm gonna have to do some testing. I did notice that there are a few test points on this board. There's a big test plug here, there's one here, and there's also a little one here. So I think what we can do is get out the oscilloscope and check some of the waveforms that are at those points, and we'll see if this board is even trying to start, because the game right now is not starting up at all. The power supply is good after I replaced the bad high voltage capacitor, so everything's working on that, but we obviously have problems on the two other boards. All right, I've removed both the driver board and the CPU board so I can do some preliminary testing. And so what I've done so far is I've removed this transistor, and it is right here. This is the one that controlled solenoid 8. It is a 2N3055. Now, how these transistors work is the two leads on the back there are the base and the emitter, and the actual case of the transistor is the collector. And I figured out that if we use the meter and go between collector and emitter, dead short. So this transistor has indeed shorted, and I checked its little companion pre-driver transistor, which is this one here, and it seems to be okay. Testing in circuit, it seems fine, and that does include the high game to date transistor and the lamp transistors that are installed there. I checked the ones that I thought were faulty in circuit, and they seem okay. So it's very possible that those lights are on just because the CPU board's out of whack. I'm not sure. I'll probably end up taking those transistors out of this board just to test them and make sure, but it is possible that because those transistors test okay, that everything that we're having issues with is on the CPU board there. So I did go ahead and buy some new transistors. I bought a new one of these. I bought a few of these and a few of these. These transistors are fine, and I have some spares if they do end up going bad. So I will update you as things keep progressing. All right, well, one thing that I figured I would do to this machine just to see if it would make any difference is I went ahead and installed the mandatory ground mods that you need to do on a System 1 machine to make it reliable, because these machines are notorious for having bad ground connections. So what I went ahead and did is I soldered a new ground wire from the negative leg of this capacitor to the cabinet, and then I went ahead and soldered a wire from the ground connection that is on this unused connector to the cabinet. And I'm going to be doing the same thing on the driver board as well. There's a spot on that where you can solder in a new ground wire, and then I will attach it to the cabinet, probably down here somewhere. Because how this machine is designed is the only way that the control board and the driver board get their ground is through the connectors here. And if those connectors grounds fail, then they won't be grounded at all because they do not communicate with the back box ground. The only board that communicates with that is the power supply here, and it only does it through these screws. So if these screws are oxidized, for example, then the whole machine's not really going to be grounded properly. So that's why these ground mods are considered mandatory, because you're establishing a direct connection between the ground on the board to the cabinet ground. And so as you can see, I did that to both of these boards. So now they will be grounded correctly. I'll be doing it to the driver board as well. And I'm just going to stick them back in real quick just to see if anything's different. I'm still going to leave these modifications in place even if nothing changes, but we'll just see if anything changes. All right, I have done some more testing with the driver board, and I don't think there is anything wrong with it except for that transistor that I pulled out here, the one that shorted, and it is okay to run this board without that transistor in there. All that does is just prevent the drop target reset from working, so it's perfectly fine that I have it connected and running like that. Because what I was doing is I was checking some of the transistors. I took the driver board out of the machine and I was powering it with my bench power supply. It only takes 5 volts, so it was pretty easy to power it up. And I was checking voltages on the board, and I was checking the suspect lamp transistors, and they all seemed okay. I compared them to good ones, and I removed this transistor from the board to check it out of circuit, and it is just fine. So I think that our issue with the lights is not a transistor problem, but is just a result of the CPU board being kind of in a weird state where it's just not doing anything. And so I think it's making those lights light up. I did check for a proper 5 volts and ground on each of these chips here, and they all had good ground and voltage. So, I mean, it could be a problem with one of those chips, but I really don't think so. But it is obvious to me at this point that the CPU board right now is not doing anything. It's not starting up, it's not resetting the game, and when I try to push the start button in front of the cabinet, it does nothing. The test button doesn't do anything, so the CPU board is just acting totally dead. So what we're gonna do at this point is we are going to use my oscilloscope, and we're gonna check some pins, and we're gonna see if things are actually trying to operate on the board. So what we're going to be checking are these 2 test plugs right here. And we're going to see if we see activity on those plugs. And I did look at this test plug here. I put my meter up to it. All that does is just show you if you have 5 volts and 12 volts, which I had on this plug. So we're going to take a look at these 2 plugs. I'll get you in view of my oscilloscope, and we'll see what we find. Well, I just realized that I wasn't recording, and I was able to figure something out with the board using the scope. So if we measure pin 14 of the first test connector, that is the reset pin. And so what we should see when we turn the game on is it'll go to negative 12 volts and then very quickly change to 5 volts. And I did see that when I turned the game on. Unfortunately, I didn't record it, but this is what that looks like on the scope. See how it was down at negative 12 volts for a second, and now it's up at 5 volts? So just with that alone, that tells me that the CPU in the system is actually alive because it's going in and out of reset. So it is trying to reset the system. So the next thing that we're going to check is the clock circuit. And so to check that, we need to look at pins 11 and 12 on the second test connector. And so when we hook the probe up to those, we should see pulsing at both of those pins. Oh, there we go. I think I might be in the way, but there is pulsing there. So that is good, and we'll go to 11. There's pulsing there as well. That means the little crystal oscillator that is on the board is actually doing its job. All right, now we're gonna check a crucial thing. We're gonna check for address and data bus activity. And so that's done at the first test connector on pins 1 through 13. And so every one of those pins should have pulsing on it. And so if at this point we don't have pulsing on those pins, then we know that one of those custom, they call them spider chips, are bad, and you can't get those chips anymore, so that would condemn this board. So I'm hoping that we're going to see pulsing here. So let's see what we see. Here's pin 1. There's pulse. Pin 2. Here we go. Pin 3, 4, 5, 6, 7. I believe this is 8. Here's 9. 9 is high. 9 is at 5 volts. Don't know if that's correct. 10 is at 5 volts. 11 is at 5 volts. 12 is at 5 volts. And 13 is at 5 volts. Okay, so we have pulsing on most of the pins, but we also have some pins that are stuck high. So I'm gonna make sure that that's actually normal. All right, apparently that is okay for not all of those pins to have pulses. So it seems like that the spider chips are actually working. All right, I'm gonna do this next bit off camera because it's gonna be pretty involved and there's gonna be wires all over the place. So the guide that I am following to kind of go through this CPU board is on pinrepair.com. Just Google Pin Repair System 1 and you'll find it. And right now I am at the step of testing the input and output buffer and the spider chips. So what I'm going to be doing is grounding certain chips and checking their output pins and see if we get 5 volts on the outputs. So I have to do that on Z29, Z27, and then on the switch matrix return chips, Z9, Z28, and Z8. So I'm gonna go ahead and do all that, and I will come back with what I find. Well, I have found the problem with this board. So I tested all of the input and output buffers and they were all good. So Z29, Z27, and Z9, and Z28 are all good. When I got down to the switch matrix strobe, that is chip Z8 right here, and testing that shows the input and output pin. It says both pins should be pulsing. I did not see any pins pulsing. The inputs were stuck at around 5 volts. Sometimes they didn't even move at all. And so the outputs were doing nothing. And so if we look down here at the explanation, it says if the logic probe shows pulsing on the input side and not on the output side, then that chip is bad. But if there's no pulsing on the input side, which is what I saw, then the U5 spider chip is bad. This is U5, and so this chip has failed. And so because you can't get any more of those chips, that condemns this board. So I will have to get a replacement CPU board for this machine. That is the only way it can be fixed at this point. Part 3. We figured out why the machine doesn't start up. It is due to a bad U5 spider chip on the CPU board. And it makes perfect sense as to why the machine doesn't start up with that chip being bad, because that chip actually contains some of the CPU board's ROM code. So with that chip being bad, we are going to install the new CPU board, and I'll replace that shorted transistor on the driver board, and we will go from there. So look forward to that, and I will see you in my next video.